So yesterday we had this, we were going to do a video on this Uniden 200. I started the video, I opened it up, there was an EEPROM board inside. The synthesizer chip's missing, they're no longer available. So I've said to the customer, unless you can find a chip from somewhere, this set is scrap. I've removed and destroyed the illegal EEPROM board. So that was yesterday's video, and that goes on the pending shelf. So we didn't see anything yesterday because of that. And that's one of the reasons we normally only do trade, because they come pre-vetted from the supplying dealer. So we have something which I don't think we've ever covered this before, and it's the Radiomobile CB202, and it's as good as it gets. You know, that is this, the Cybernet Beta 3000, the Ford Roadmaster 505. You know, it's as good as it gets. So I can't even remember what he said was wrong with it, so to be honest, it really doesn't matter what he says was wrong with it. So let's hope there's no surprises in this one, eh? So I'll just check the fuse. Two amp. Good, that's a great start. So we'll open it up. No, I mean, not apart from that, what on earth's happened there? Well, I may as well take the bottom lid off. Oh dear, what's happened here? So we've had a lot of soldering round this area, the VCO, and then we've got wires that are taped together for some odd reason, and we have an electrolytic capacitor right down there which has seen better days because it's really starting to have its sleeving recede. I just don't know what happens to sets, I really don't. So we've got a wire that goes nowhere and two that are joined together. Oh, you know what it is, don't you? Ha ha ha. It's high-low power. So we'll need to restore that function. I know why they do it, they inadvertently catch it, but then you've lost the low power function, which is very useful. Okay. It took some doing of my brain. Right, let's power it up. And select a microphone. We're not having customers' mics coming in unless we put them through the dishwasher. So, I think what we need to do with this is look for a scrap piece of paper and write down how it's working at the moment. Right, start with transmit. Radiomobile. Somebody put, what language are you writing in? When I was at junior school, the teacher said, Richard's writing has gone from bad to worse. Another teacher says, your writing looks like a spider has jumped in ink and walked all over a page. And I said, well, in the future, nobody will bother writing anyway. It will all be done on computers. And of course, I was right. But here I am, sat here, 50 years later, and writing in my usual scrawl. Transmit. Oh, that's going to have to come down. It's doing 5 watts. Is that balanced? So, it doesn't transmit on channel 40. Yeah, this is the issue, you see. It doesn't start transmitting. It's 31. Doesn't start transmitting until channel 35. So no channels above 35. Deviation should be 2.2. Wallow. Are we not tuned in? I didn't expect that to happen. Wallow. So it's transmitting at 4 kilohertz. Deviation, that should be 2.2. So it's so loud it's going on to other channels. It's a bleed over generator, this radio. So the frequency, let's just have a look at that together. Should be 27.79125, 27.79192. So it's off frequency high, but it is within spec, so that's not too scary. And we can, you know what, we'll do that now. We can just find where the trimmer's gone. You know it's had finger trouble because it drops naturally with age, doesn't go up. There we go. So we've done that. Now we'll just look at receive. So for 12 decibel cyanide, it's 0.45 microvolts, so that's fair enough. For 10, 0.41 microvolts, and for 20, which it does, not all sets do, it's 0.85 microvolts. We probably won't improve on that. That's good. And we'll worry about the squelch later. Right, let's get into this transmitter. So we need to get all this. It's all right doing 5 watts when you're only entitled to 4, and then it only works on a few channels. Yeah, great. So we'll set up the VCO, and the first thing we need to do with that is to earth our crocodile clip. I ordered some more crocodile clip leads from RS, and they're on back order. I'm going to have to start picking them up off the floor. So we'll just connect that. Oh, the earth tag's missing between the 2 coils. Well, that you know, that capacitor shouldn't be there. You know what somebody's done, don't you? They've done one of those illegal 80-channel modifications, and they've had it removed. So we'll remove that and put it in the bin. And we better add that missing earth strap. You know what? Instead of getting a piece of wire, it might be quicker to actually recover one off a scrap chassis. Subject to having a scrap chassis. Yeah, so I'm concerned that the VCO core is not going to get its earth, and that could be one of our problems. I'll just see what the VCO voltage is as it stands. So on receive, we're on channel 20. .4, and on transmit 4.9, which is too high. Okay, well, it seems to be getting an earth from somewhere, but I'm still going to put one on because that's how it's supposed to be. I said many times that one of the snags we've got at the moment is that most of our stuff's in storage, whilst we'll have an extra building built, which is to do with the organ end of the business. I'll just cut this bit of wire off this radio. Okay, so now with a bit of multi-strand wire on there, twazzled sufficiently, that'll give us a good anchor point for the earth. At least we know it's done as it should be. So we'll connect our meter to that point. Select channel 40 on the radio. And once again look at the service manual because I've already forgotten from the other day. So it's channel 40 and we're looking for 4 volts. Right, so the far point of resistor 4, go to transmit, so it's a trimmer capacitor at the back there. I'm going to waggle that round because it looks like it could be dirty. .92, that'll do me. So now on receive, let go, it needs to be 4 volts with the coil. feels like it's broken, but I wonder why it's right at the bottom. So there we are on receive. Oh, look at that, 4 volts to the dot. So go back to transmit. It's now changed. .89, that'll do me. So back to receive, and that's 4.02. Back to transmit, 3.9. So go to channel 1, and we should now have between 1.8 and 2.5. So that's receive, that's transmit. Back to channel 40, 3.9, 4.02. So that's the VCO reset. That was a bit finicky. So we'll put the meter away. That should be done with, unless something unexpected happens. So now we'll go over to the. That's brought it up to 5.5 watts now. Right, we'll select channel 20, and we'll go through the tuning of the PA. And this time it will be balanced. That's a broken core, but it still moves. That's now peak. That's a broken core. That's so broken I'm going to have to remove it. Okay, so with the various tools we have here, I've been able to remove the broken core from the top without unsoldering it, and now I'll put that in the other way round like a 300-year-old cottage doorstep. And now we can tune that back up again. That's a false lock point. Here's the correct one. So there we go, 5 watts. I'll just go on the preceding one. That's still okay. So we want the green plastic tool next. Maximum. Maximum. Core's broken, and that would be maximum. I'm going to have to unsolder that, there's no way out of it. Okay, so we'll try again. So replace that, found a core in a Fidelity 1000 scrap chassis. Helps if I switch the radio back on. So we've got the peak there, it's just about 5.5 watts. It's dropping as the radio heats up, of course. So we need to look at the instructions again, because I can never remember this bit. We need to set coil 4 to 4.4 if we can, clockwise. So that's now reduced it to 4.4, and then anti-clockwise with L9 to bring it, they say to 3.8, well we bring it to 4. So we'll now check on channel 1. 3.5 watts, not good enough. Now we'll check on channel 40, 3.8 watts. So we're going to have to do better than that. Channel 20. So 4.1 now on channel 20. Spot on 4 on 40. 3.95 on 1. Let's see if we can bring it up with the other one, that fraction. So that's now 3.9 on one. No, this isn't working out. Four on channel 1. 4 and a fraction on channel 20. Four and a fraction on channel 40. Right, we've got 4 on 40 and 1. And 4 and a fraction, like 0.02 on channel 20. So we're there. And it's now working on all 40 channels. Right, that's that done. Let's do the deviation. That was all messed up, wasn't it? So we need that to centre, which it is. That reducing to 2.2. While it's not like AM where when it's louder there's more modulation, it carries better. It doesn't work like that on FM. It's got to be right. You end up with actually less range. So that's only speech processing is going to give more talk power, and the op amp in there does the speech shaping on this type of radio. So we've balanced that up as well, because you've got the AGC mic gain thing in flop there. I've done that to centre, which is normal. So we've done the frequency. We need to see what the meter's saying for what it's worth. And it's lighting all 4, which is what it should do. But I'll just make sure it's only just lighting all 4. In fact, I can't turn it down. Why is that? I need to do that, and I can't do that without having the low power function. So I'm going to have to restore the low power function. So, okay, back to transmit. Full power's full power. Low power is about 500 milliwatts. So we'll just make sure it's 400 milliwatts where it's supposed to be. One of those, is it? There we go. So now I can set the meter, because the manual says it's supposed to be 1 bar. Wallow, 1 bar. And on full power, all the bars. So that's that sorted. Okay, so transmit's done. Let's look at receive. And if you remember, it was about spot on receive. So let's see how spot on it really is. So we'll start with looking at the oscilloscope with an S9 signal. There's an S9 signal, 100 microvolts, and where's the tool? There's the tool. So we'll look at the detector. We've actually gained a fraction. That could help us on the 20 decibel setting. So now we'll look at the cyanide meter. Set that to about 4 decibels. Go through the front end. My goodness, that's a huge difference. And there's me thinking it was pretty good. I think they've got the exceptionally good set here. Put that to about 12. That's that one. Put that to about 18. There we go. Just have a final look at that again. Excellent. So we'll look at that now again. So that's before, that's after. So we'll start with the 20 dB. Funny if it was worse, wouldn't it? It's now, make sure we're in the right setting. Yeah, 0.4. You're joking. 12. Naught 0.23 and 10, 0.21 microvolts. So quite a marked improvement there. Let's see what we can hear it down to. We can't hear it off the clock, but we can hear it down to point. Get on the right scale. 0.1 we can hear it down to. So that leaves us with the S meter. So back to an S9, and it should be just touching the fourth light there. So we can drop that with the signal generator. That's that set. And now the squelch. So I want to be able to squelch out what we're hearing now, which is 30 microvolts. And I'll put the camera onto the controls. So 30 microvolts, full squelch, and it's not squelched it out. So we'll adjust the preset. There we have it squelched out. So moving the signal generator to 100 microvolts should bring it in, and back to 30 microvolts disappears. So that's the coarse end set. Now we'll look at the other end. So I'm parking the signal generator at 0.3 microvolts. We'll drop the squelch on the radio to threshold, and then we'll switch the signal generator back on. Now it hasn't come in, so let's see where that squelch now is. So it's coming in. It's coming in at about 0.7 microvolts, and it's leaving us about 0.6 microvolts. So not as sensitive as some. Perhaps we can set the squelch that a little bit finer. I'll give it a go. Try again. Yeah, we can. Yeah, I mean it's coming in then 0.1 of a microvolt. You know, so yeah, you can get it if you're careful with the squelch control. Right, I think that covers it. I think we ought to just look at the output on the spectrum analyzer, just in case it has been messed with. And I just want to change that electrolytic capacitor, see what it is, because it just looks like it's not in the condition it ought to be. So it's the one in the naughty corner, C122. So look at it on the circuit. I can't honestly say I can see it quickly. Anyway, we'll get the power off, we'll get that changed. Right, so that's cleaned up some of the previous bodge under there. That looks like a wicked dry joint. So I'll just do this. You see, when you start defluxing, you can see other little snags. So we've done that. So it's clearly had some major VCO issues. Somebody that sometimes had an illegal 80-channel modification, that's been removed, thank goodness. And yeah, we seem to now have a nice radio. Very good receive. I'll let that dry and then we'll put the lids on in about half an hour. I'm not in a push today. Oh, well, I'll tell you what we'll do. We'll just check this capacitor. Now, this is 220 microfarads at 16 volts, and I've put in 25 volt rating. Not that I needed to, but we have those handy. They're smaller than these were because time's moved on. You see, it's just that it's receding as if it's been hot, and that just worries me. So we'll just put it on the SR meter and see what we get. $240. It's a bit, you know, you start to think, is it starting to fail? Anyway, in the bin it goes, and I'm sure that will be all of about 16 pence for the customer. I think we can put the bottom lid on safely. Right, so let's go over to the Zytargi meter before we go any further. So we know what it's doing on the test set. Let's go back to that camera. Select channel 20. And it's doing, oh, it's doing nearly 7 watts on the Zytargiometer. Mind you, cold, it's doing 4.5 watts on the real meter. Okay, so let's look at the spectrum analyzer. So there we have 27,79126, it says. Not much of a discrepancy there. Let's have a look up the road. Minus let's reset that. I think that's reduced it to within spec. So in this case, it was moving that coil down slightly to detune it. We're still doing. I'll just go to the other camera. We're still doing 4.1 watts as a relatively cold set, and I'll just check it at the channel edges. Channel 40, 4.1 watts. Channel 1. 4.1 watts. So just try and bring that to, because it's now uniform throughout the band. We'll just see whether we can just pop that down to the the legal maximum. So detune that anti-clockwise, and there we have 4 watts. So that should be the same now on the other channels, hopefully. Well, 4 and a tiny bit on that one, and on channel 1, 4. So there we go. We're done. So we'll put that back on the speaker. Okay, here we are now on an aerial with the Radiomobile 202.
I think you mean 20 now. Don't you mean 20, Jamie?
Oh, good grief, somebody with an echo. Oh, there's a bit more activity today. Well, it's about 6 o'clock. 19, Roger. Right, well, we'll do an on-the-air test with that later on. I've no doubt that'll work great, because they always do. So thank you for watching the Radiomobile CB202 from 1981.